Hello guys, welcome back to my YouTube channel. We're still under strain and stress. So I've given example 1.10. It says a steel cable with a diameter of 20 millimeter is 20 meter long and must lift a load of 5 ton. Say A says determine the stress brought about in the cable. Calculate the stress brought about in the cable. So far, if you can check the data there, what are we given there? What are we given? We've given the steel, we've given a diameter which is 20 millimeter. If you divide by 1000 will be 0.02 meter. The length, if you divide by 1000, will be exactly is the diameter, right? Must lift the load. That is a load, but we know that load is simply force, but we know that must be mass multiplied by what? By gravity, isn't it? But then there we know that 1 ton, the proportion 1 ton is equal to 1000 kgs. Now if you have 5 tons there, you have 5 tons. What about the kgs? Cross multiply, know your maths. As you cross multiply, you have x, that because it's 1, then that side you'll multiply, that will be 5 multiplied by what? By 1000. Then remember this represent kgs. Then what will be that x? 5000, isn't it? Good. Would be 5000 when obvious is 5000. So yeah, that is how you apply this thing there. You have 5000, but now you have 5000 what? Kgs. We have kgs, but okay, here it's 5000 kgs multiplied by 9.81. Now will become in Newton. 5000 times 9.8 times 9.81 simply equals to 49050. It's Newton now. Okay, we have the force so far into our data. Right now, what else are we given? We are done with our data actually. So let us A says determine the stress brought about the cable. We want the stress. A, we know that stress actually, you guys, this part we know that stress is force over area, isn't it? So we'll have to calculate an area. Right, we will need an area to calculate force. We have here on our data. Okay, let's calculate an area. Pi over 4, remember we've given. So you calculate the area of a cross section, that which is the circle. Pi over 4 into our diameter. Remember it was 0.02. Square this body, you multiply, punch this on your canvas or on your calculator. Then this guy will give you 3. This guy will give you this guy will simply equals to what? Say as after finish punching, I got 14,159 times 10 to the minus 6. This would be, we have measured in meter squared or square meter, which is the area. It's fine, we have the force, we have the area. Now we can strictly substitute our stuff there. Force is 49050 314,15 times 10 to the power of minus 6. Then if we punch those guys, ladies and gents, what we'll have there, we'll simply strictly have 156,131, or simply megapascal. I will leave this in megapascal. I don't know what that long number, this will be simply just megapascal. We have that. Okay, what about BP? B says determine the change in length. No, the change in length is simply X, extension, right, of the cable with Young modulus. You've given a Young modulus of 210 gigapascal. We want the change in length, or we've given G is equal to 210 gigapascal. So we know this. You can use in, because you have you can use, it's up to you. Use this one. Remember, it's force over area multiplied by E, or you can use this one, stress. Remember, you've calculated the stress, isn't it? Multiplied by length over E. Remember this, what is that? Force over area simply equals to stress. You can use either of the two. I will go with this one, is because, yeah, it's up to me. Leaving that one, I mean the same thing. The force just I've calculated. Also here I know the force. There is the force is this one that I've calculated. I've used there, which was 4,950 multiplied by original length. I remember it was 0,2, which is, we remember it was 20 millimeter. So then area, we've just calculated it there. Currently there, it is there. Here it is. There is 314,159 times 10 to the minus 6. Multiply again by modulus of elasticity. I don't know what I've wrote here, but I know this is E. 210 times 10 to the power of 9. Remember that is gigapascal. If you strictly punch this occurrence, you'll get this to be equal to, this is your extension, 14. Let's say you'll get your extension there. Remember there, if I punched, get 0,014. If if I round it, let me round it here. Let me just say 9. Round it to that decimal, or I cannot. Let me just not. Okay, let me not round it. Let me leave it like this. Then, if I don't round it off, let me just multiply this by 1000 to be in millimeter. Then multiply this by 1000. We'll have 14,87 millimeter. Remember, when I multiply, then this is our extension. For argument's sake, if you wanted the final length will be equal to extension plus the original length that you've given. So yeah, that is it. So guys, thank you for your time. Please do not forget to subscribe to my YouTube channel. Right, don't forget to subscribe there and click that notification button so that you'll be notified whenever I post a new video. Feel free to comment and share this to your fellow classmates. Yeah, you can, as you are, sorry about this, as you are subscribing to my YouTube channel, you help me to grow this YouTube. As you can see, this YouTube is still new, guys, so show up there, then you will motivate me. I will keep posting some more and bringing you nice content. Sharp.